Hello, my name is Marcus Cote, and this will be the first time I'm trying a video like this. I am going to be demonstrating the refurbishment of a Helzel WERA 13.5 MHz antenna coil. I want to start out with a quick disclaimer that these steps are a product of tinkering and trial and error, and the information to be shown has not been received from the manufacturer. So, why would an antenna coil need to be refurbished in the first place? The answer is that in the field, when these antenna coils were plugged into a vector network analyzer, they showed a very high standing wave ratio, or SWR, at the working frequency of 13.5 MHz. An attempt to tune the antenna was made, but the behavior did not change. Additional troubleshooting can be done with a digital multimeter, but that is beyond this video. The basic tools needed are 2 pairs of channel locks or pliers, some electrical contact cleaner spray, such as a CRC QD contact cleaner. You'll also want a small straight metal pick, a No. 1 Phillips head screwdriver, and a 3mm hex wrench. There's 4 basic parts to these antenna coils. There's an aluminum rod that seats inside of the 2-meter antenna pole. There's a plastic insulator section that holds the windings. There's a metal base section that serves to attach the antenna ground wire, cable connector, and radials. And there's a set of 17 copper windings that connect from the top section to an end-female connector on the bottom of the coil. I am first going to use my metal pick to remove 3 of these silicone plugs that are sealing off threaded holes in the coil. There's 1 hole in the top and 2 holes in the plastic section. These holes contain small set screws that can be removed with a 3mm hex wrench. And there's also 2 areas of silicone to remove where the copper windings enter the plastic section of the coil. With this step complete, I'm going to use a No. 1 Phillips head screwdriver to remove the 4 screws that hold the bulkhead connector to the coil base. For this step, it is crucial to use a No. 1 Phillips head screwdriver or driver bit, as these screws can be quite seized in the base and easily stripped out with the incorrect size bit. I found a T-handle screwdriver to help break these loose without stripping them. If they are still stuck, you can try a penetrant spray, such as PB Blaster, or gently apply some heat with a torch. As a last resort, if a screw has been stripped, it can be drilled out, but the base may need to be discarded. With all the fasteners removed, I will now try to work out the end of the copper winding from the top section of the coil. You can use your pick to gain some leverage, but you don't want to use too much force and risk breaking the copper winding. With some patience and the use of the pick, the lug on the end of the winding will eventually slide free. At this point, we are ready to unravel the winding. Gently unwind the copper, making sure not to leave any hard bends or crimps. With all of the copper unwound, we can start to feed the winding out of a small hole through the center of the coil base. In this example here, you can see standing water, dirt, and corrosion inside of the base. This is the likely cause of the poor tuning characteristics we observed in the field. We'll continue to gently feed this wire out of the hole, trying our best not to scrape off the enamel coating on the copper wire. The end may be a bit tricky to get out, and you can use the pick if necessary. The next step will be to unscrew the base and top of the coil from the plastic section. These may be too hard to turn by hand, so you can gently grip it with pliers if needed. I'll do the same thing for the top and bottom sections. Now, the coil has been completely disassembled into its base components, and we can move on to cleaning and reassembly. I'll use the contact cleaner spray, a microfiber cloth, and some cotton swabs to remove all dirt and corrosion from all of the components. With all the components nice and clean, make sure to put the rubber O-ring back onto the winding before inserting it into the coil base. Next, I'm going to cut a 2-inch long strip of electrical tape, and I'm going to apply this to the copper wire immediately after the end-female bulkhead connector. The point of this tape is to prevent any potential contact between the winding and the small hole in the coil base, which could cause a short, especially with water or swelling from corrosion. Now, the winding can be fed all the way back into the coil base, and we can begin to firmly wrap the copper around the plastic. Wrap the copper until you are essentially out of length for any more windings. The copper should be near the hole in the plastic, and just have a small amount of length left to be inserted into the hole. If there's a lot of slack left, you need to make 1 more winding before inserting the end of the copper into the hole. The lug on the end of the copper may make it a bit tricky to feed into the plastic, and you can use the pick to help. With the correct number of windings, the lug on the end of the wire should extend just beyond the plastic, while the windings are nice and tight. Next, we can apply a small amount of contact grease to the threads on the top section of the coil and thread it back onto the plastic section. You want to carefully position the lug on the end of the copper winding into the hole on this piece. If done correctly, you should be able to see the lug of the copper winding through this hole in the top section of the coil. Now, the screw can receive some contact grease before being tightened back into this top hole. Firmly tighten the screw so that it holds the top of the winding in place. The remaining 2 set screws and the 4 Phillips screws on the bottom of the coil can also be reinstalled with some contact grease to prevent any future seizing. Finally, a wire brush attachment on a drill can be used to remove any oxidation and corrosion on the top aluminum section of the coil. As a last step, some clear exterior-grade silicone can be reapplied to cover all exposed holes. At this point, the antenna coil refurbishment process is complete, and the antenna coil can be tested and retuned on an antenna for your coastal radar system. I hope you enjoyed the video. This has been Marcus Cote. Thank you for watching.